Well, thanks for that introduction. It's wonderful to be here. I can't see any of you, but hopefully you are all still here. My name's Mike. I'm CTO at a UK-based prop tech company called StuRents, and it's great to have quite a few of our team here with us today. And if you want to interact with me, you can either talk to me after the talk or through the conference, or you can follow me on any good Fediverse instance. I'm at m1ke at phpc.social. My talk today is called Your Software is Mission Critical. But first, who remembers this? The double rocket landing of the SpaceX Falcon Heavy rocket. For those of us who watch this live, you will remember not only being amazed by the process of these rockets coming down together, but just how smoothly everything went. For things like this, not just the landing, but the entire spaceflight process, software is not just essential, but must be absolutely perfect. The thing is, for many people, the experience of software is a bit more like this. Head in your hands, wondering why it's gone wrong again, such as why my toolbar has appeared on the side of the slides. We don't know, but these are the things that happen. Or maybe it's something like this. This was a quote in an article in the New Yorker last summer. People were noticing that there was something about these systems that had an impact on their lives. This article was called The Age of Algorithmic Anxiety. The fear that people had that algorithms that they didn't understand and that they didn't trust to have their best interests at heart were somehow spoiling their lives. And they were anxious about this fact. And when we look at these things, this view people have of software, we have to wonder why they have that. Why has that become the state of software today? I think in one part, attitudes like this might be to blame. Move fast and break things. Unless you are breaking stuff, you are not moving fast enough. Now, this quote, attributed to Mark Zuckerberg, popularized in the movie The Social Network, has, I think, typified software development over the last decade or maybe more. And it was a strange thing. When I was looking for this image to put in my slideshow today, every time I found this quote, it was against these sort of Zen, wellness-like mindfulness backgrounds. And I didn't feel that was appropriate. So I've made my own. Now, the thing is, it's easy to dunk on Mark Zuckerberg, and so I'm going to continue. But we all know one thing, and that's that we are the people who build software. The people here in this room. And the reason I'm opening this conference with this talk is because I want to encourage us. We're at a brilliant place for the next 2 days for learning, for gaining experience in how to do things that we've not thought about before. And I want to encourage all of us to see just how important that is, to see how helpful this conference can be to the way that we interact with what we do and the way that what we do interacts with the world. And so, let's get on with it. So, why mission critical? Well, mission critical is not something that has a canonical definition, but it looks good in a talk title, and hopefully when you all saw it, you came. I mean, you're here, right? And I wanted it to evoke an image like this. This is the Airbus A380, the largest commercial passenger jet ever created. It was ultimately an unprofitable aircraft for Airbus. One of the main reasons for that was significant delays in its production. And in this huge aircraft, a double-decker aircraft, 4 engines, a huge amount of metal, one of the biggest challenges in building it was getting the software and the electronic systems to talk to each other. When you have something like an aircraft, software is mission critical. And as a sad illustration of this point, we have another aircraft. This is the Boeing 737 MAX. In late 2018, early 2019, 2 Boeing 737 MAXes were involved in fatal air disasters, killing everybody on board. In the subsequent investigation, one of the key factors in both crashes was determined to be the autopilot software, which had fought the pilots all the way to the ground. When mission-critical systems fail, people tend to be on the losing side. At this point, you might be thinking, well, I don't build autopilots, and we're at a PHP conference, so that makes me quite happy. But the thing is, software is everywhere. It's in healthcare, finance, defense, transportation, things that keep the world running. It's also in the really boring, everyday stuff. Interacting with the government, paying our bills, buying food and education. And it's in the way we get away from the world. Cat gifts, Social media. 27 different streaming services, why won't they stop? And of course, more cat gifs. And this is where I have to bring back our sad-looking man. And I'm going to give him a name this time. I'm going to call him John, because this story I'm about to tell you is about a real person called John, who I know. And John was buying a house. You know, buying a house is a pretty significant step in anyone's life, especially at the moment. But he was in that process. It's a long process. It's a complicated process. It's a stressful process. And as part of the process of buying a house, he wanted a simple request, which was that when he moved in, he wanted to have internet access. And like many of us, John worked from home. Internet access, pretty important when you move into a new house. So John called up a company and asked them for one of their finest internets and said it needed to be delivered about the time that he was moving into the house. He didn't quite know, but it was going to be a few months at least. They said, yes, we can do that for you. Get back in touch when you know moving date. And he moved on with all the other things you have to do to buy a house. 2 months later, John gets a phone call from his bank to tell him that they've withdrawn his mortgage offer because of a sudden and unexpected fall in his credit rating. When he drilled into this, he found out that it was because of unpaid internet bills. The company that he'd called up and asked for to provide internet had been billing him at the house that he didn't live at. So he hadn't been receiving these bills for an internet connection he wasn't using at a house he didn't live at. And the subsequent strike on his credit record for not paying his bills lost him his mortgage offer. John went from the heights of buying his own house to being practically homeless, all because of a software system. What's the problem? We can summarize this as mistakes made in software development lead to errors in live usage of the software. But the result on people is much deeper. Anxiety, loss, stress. At this point, it might be easy to say, well, the software was the problem. The software was the issue. The software let them do a thing that they shouldn't have done. I love this quote from Mitch Radcliffe: "A computer lets you make more mistakes faster than any invention in human history, with the possible exception of handguns and tequila." Last time I gave this talk was in Texas, and that got a bigger laugh. And that's what we're looking at here today. The computer lets you make mistakes. You're still the one making them. It empowers you to make them faster at web scale, but you're still the one making those mistakes, and they still have an impact. Before we get into the rest of it, I want to do some clarifications. What we're talking about today is how we build software and the unintended negative impact of that. There are cases where people build bad software or build benign software and sell it to bad people. And there's great talks and great books written about those facts. They're worth looking into. This talk isn't about that, and we're not going to cover that area, because I'm assuming, hopefully, the general case that most of us are not trying to build bad software to do bad things, or selling our software to bad people. The majority case, our software is good to neutral. But that still doesn't prevent indirect harm. We can still make mistakes with how we do what we do. I believe that it's our responsibility as developers to get this right. So, how do we do that? Well, number one is testing. There's a surprise. It turns out everyone has a test system. Some people are fortunate enough to have a separate production system. And in this conference, again, there's talks on testing. I advise you to go to them and learn about this thing, because it's very important. It seems obvious that if we don't test, things break, and yet it's something that often gets skipped out. During this talk, I want to look at the mission-critical way of doing things and see how that can inform us. The Federal Aviation Authority in America has a number of guidelines, as you might expect, for aircraft and airline systems. And they're written in a sort of jargon, very dry format, but I'm going to read a few of them out. In this one, it says processes must have well-defined entry and exit criteria, according to DO 178C, and a project must show it's respecting those criteria as it performs the activities in the process. Now, helpfully, the language in most of these documents is so dry that even the aircraft software community has taken it upon themselves to provide summaries of these. And I found a website that was doing just that, and they said this: say what you are going to do before you do it. And people might recognize this as test-driven development. In test-driven development, if you've not come across it before, you write a test for an expected outcome. You then write some code to pass the test. And then you make the code nicer, whilst ensuring the test still passes. That's known as refactoring. And test-driven development is a great principle. When people hear about it, they see the value in doing it. But it can be much harder to put into practice than in a theoretical exercise. What about our legacy projects, the things we've been working on for a long time, which, let's face it, is what most people are doing. The code you wrote yesterday is already legacy. In testing, there's a traditional pyramid of the type of test you'll have in a system. At the bottom, we have our unit tests. The unit tests are the most numerous, hence they form the foundation. They test the smallest different parts of our system and how it interacts. Then we'll have service tests or integration tests, connecting a database or a file system, maybe an external API. And finally, at the top, we have our UI tests, our user interface, end-to-end acceptance, browser. There's loads of words for the UI level. We'll often have the fewest of these. They tend to be the most complicated to write. They tend to be the most brittle and break often. And they tend to take the longest to run as well, because you're simulating real user actions. And so, together, these form a pyramid of our base and our top level of our tests. But I find this sometimes hard to apply if you're bringing tests into a system that doesn't have tests yet. So I've tried to adapt it a little bit to cover some things which might help people. Step one is to actually test some stuff. The foundation of your testing strategy doesn't need to be a specific type of test. It needs to be the fact that you're starting to do testing of any format. In fact, in a legacy project, you might find that your UI or browser tests are the best place to start. Hopefully, you have an application that at least works for some of your users. So simulating their behavior in a test format is a really great way to start adding safety to your application. Once you've done that, you can start changing internals to allow it to be used for unit or service testing without thinking you'll break the whole thing for everyone. Once you have tests built, any of those tests, you want to look into continuous testing. And by this, I don't just mean hitting enter repeatedly. Continuous testing using a system such as GitHub Actions, Bitbucket Pipelines, CircleCI, Jenkins, there's many others, and again, there's talks on that in this conference, are great because they can run your tests every time someone pushes a commit, every time someone opens a pull request, every time you want to do a deploy, various strategies to ensure that these tests keep running. If you don't keep running them, they'll go out of date or they'll break, or what's the point in having them? And finally, increase our coverage. Once you have this base of your pyramid built, you can look at actually increasing the coverage. How many parts of your application are you covering? And there's ways to improve the coverage of our testing. Collecting metrics. Tools such as PHP Unit combined with Xdebug can give you code coverage statistics on how many lines of code are run in a test run. Targets in your pull requests. Tell people that for every pull request, either new code must be covered by tests. Maybe not the old code, maybe new code. Maybe every pull request has to cover a little bit of old code as well, just so people start to move the needle. And I would suggest for teams who are getting into testing to avoid covering brittle features, things that might break a lot. Ideas in this area are things like in a browser test, where you might say, click the submit button. And then someone thinks, submit's a bit of a weird computery jargon word. Let's change it to save, that's nicer. And then your tests break. There's no quicker way to put your team off testing than making simple, helpful changes in your application, break the tests, and require everyone to do the work twice. So think about when you bring this into an organization, think about how you're going to encourage people that testing is a good thing, not just something that gets in their way and slows them down. It will maybe slow it down a little bit, but let's not frustrate people. Or we can take a different angle, another mission-critical way. When I was studying for my degree back in the 2000s, I remember reading about a piece of software that was able to mathematically verify every possible runtime outcome of a computer system. And so I did some research on this when writing this talk, and turns out this software was called ASTREE. This was used in the Airbus A380 to verify the absence of runtime errors. What this means is the software was able to analyze every possible function, every possible input and output, all the ranges, which you might think that's crazy, like integers have a very high range. But they could work out what ranges were possible and what the outcome of every possible input to output would be, and tell you that there will be no runtime exceptions, no e-fatal errors during the operation of this aircraft, because you don't want to be trawling through logs at 30,000 feet. And that's a pretty complicated, comprehensive mathematical system. Probably quite a lot for your e-commerce site. But in PHP, since PHP 7, we have access to a tool called the abstract syntax tree. This allows PHP applications to read the code of other PHP applications and tell you how they're going to behave. And because of that, we have a number of tools, but the biggest ones being PHP Stan and SAR, which are static analysis tools. They can look at your code without running it and understand all the possible ways that code can go, all the possible data that can pass between systems, and therefore all the possible times you can get an error that you don't expect. They even add new features to the language, such as generics, and they can do other clever things like telling you that if you have two conflicting logical statements, that the code in one of them can never be run. And I would say out of all the things I'm going to talk about in this talk, this is the thing you can use most practically straight away. If you're not yet using one of these tools, go back, maybe in the lunch break, but maybe you can wait until Friday, I'll allow it, and start using one of these tools. There is no reason not to use one of these tools. They both have a baseline system, so that when you first run it and get 10 bajillion errors, you can just happily ignore those, so you can start to improve your project. And then you can do sprints with your team, where we try and smash 100 of those errors in a few days and get that down over time. You will build better software using tools like this, and combined with your testing that makes sure your application works. And what's the benefit of these? Well, tests ensure that code changes don't break applications. And systems build trust by being more resilient. Remember earlier we talked about anxiety. The anxiety wasn't caused necessarily by the system doing the wrong thing at the time. It was people's fear, built up over time, that the systems were going to do something wrong. People have been taught not to trust software systems, that they will go wrong, and that brings in anxiety, worry about what will happen next. So people can rely on software that always does the right thing if we build that resilience into our systems. Now, no testing strategy in the world will help if we've built the wrong thing in the first place. So next we're going to talk about design. Once again, the mission-critical way can inform us here. Back to our snappily titled FAA DO178C article. Once an activity within a process has been defined, it is generally expected that the project respect that documented activity within its process. We should write down how we're going to behave, and then the system should behave in that way. We've defined what we want to do in our system, and the software should then meet those definitions that we've decided on. I looked for some diagrams of different software development methodologies. We have waterfall, considered the old way, and then there's a vague graph that's sort of agile, but sort of not, that suggests a new way. If you notice, the agile graph there is just tacking the end of waterfall to the beginning, so I think it's a bit of a cop-out, and it says sprints in the middle, but it serves a purpose. In both these cases, old way and new way, fully half of the steps are about design. And yet, in actual reality, one of the things that sprint means for most developers is to sprint straight past the design stage. And why is this? I'm not just here to call out developers. There's a reason that we sprint past the design stage, that we ignore it, that we don't see value in it. And I think there's two contributing factors. One set is that when we design something, it's thought out from a very high level, it's written up, and within about 2 days of starting the project, the thing you're building completely diverges from the design because you realize all the problems and the assumptions the design made that were wrong, all the constraints you had to violate to build what you actually needed to build. And so the design becomes this dusty thing in the corner that vaguely describes what you once intended to build and bears no resemblance to the actual product. The other factor is if a design becomes a shackle around you. The design prevents you innovating, prevents you taking the initiative, prevents you doing the best thing. The design becomes this nitpicking, oh, it doesn't do that, what it says in the design. Well, maybe the design's wrong. In both these cases, developers won't see the value of design. You're either ignoring it or you're being controlled by it in a negative way. Design shouldn't just stop when we get to the code. If we want the design to be relevant, to stay as agile as hopefully our development practices are, the design needs to come with us. In the book Domain-Driven Design by Eric Evans, it says this: to create a supple, knowledge-rich design calls for a versatile, shared team language and a lively experimentation with language that seldom happens on software projects. If you haven't come across the term domain-driven design, that's something to look up. And in domain-driven design, as we can see, the issue here is about communication. It's about language. This isn't necessarily about what our code should do at all, but it's about our team talking a shared language. As developers, our language is our code. So the shared language has to involve our code. Our code has to evolve with our design, and our design has to evolve with our code. Our code should describe what our system is doing. We're not people who assign variables. That's not our job. Our job is to build systems, and those systems have a design and a reason for existing. As an illustration of this, a few years ago at this very conference, someone gave me a great expression about an aspect of domain-driven design, which is to make the impossible inexpressible. Our code should be a representative of the real-world factors of our system. If something cannot happen in the real world, either in the real physical world or within our business constraints, our code should make that not possible. Now, a simple illustration of this is the concept of a value object. In this situation, we have a user who has an email address, and hopefully everyone can see the slides, and we'll see that that email is not valid. It's not got a dot something at the end of it. So if you send an email to that address, it won't get there. And similarly, in PHP, at least prior to read-only properties, we could do this. We could pass an object into a function, and we could do something like set the email to an empty string, and the external context has no idea this has happened, sends that email. That email doesn't get sent, and once again, what's the result? And the value object is a way to get around this. PHP's type system doesn't handle email. String is the best thing we can represent it as. It's a series of characters. But we can build our own. In this case, we have our email. We use our best email regex to parse it, and we create our email. And now the user takes an email object. It's now impossible for our system to have a user who does not have a valid email address. Yes, the system will still break when we do create test.email, but it will break at the part where we say, get that email address. And we'll know that that's what was broken. Before we try and send the email, we've never even got close to sending that email to the wrong place. What about in John's case? Bring back our sad man again. Well, in John's case, the issue was another fundament of thinking about design. And it was thinking about what an account is for this utility company. What is an account for a utility company? Well, maybe it's the house that they're supplying the utility to. The house is where the connection goes, but the house doesn't pay the bill. I wish my house did. The bill is paid by a person, by a human. But there is no rule in the real world that says that a human has to live in the same house that they're applying for a utility for. A human can live wherever they want. They can receive mail wherever they feel like. And so in this case, the company had missed something, that the person and the property were different things, and together they made an account. And their system could have reacted in two ways to this. They could either say, well, the person has an address and the property has an address, and the two must match. So we ask you for your address, we ask you for your property address, and if the two are not the same, we say no. You can't do that. So we stop them at the point before the mistake is too bad. They might be annoyed, but they've not gotten into debt. Or we make the rule that we send the bill to the bill payer. The bill payer is not the property, it's the person. And in that situation, John's predicament would have been resolved as well. He'd have got the bills to his current house and been able to pay them. So when we look at combining design and testing, good design means we know why we build what we build. And well-designed software understands the use case, understands the real-world constraints in which it exists. So people have their needs met by software that understands them. Now, testing, design. You may be wondering where you're going to bring these things up. How do these work in your own organizations? How can we actually put these things into practice with the various constraints around our businesses? And I struggled a little bit with a title for the next section, so I decided to call it Time, Money, Diversity, and Management. That seemed like a bit of a mouthful, though, so I've just named it Humans. We are humans, and primarily we're building software for humans. Humans are the top-level factor in all of this. That's what we're doing. And in this area, even mission-critical systems are starting to fail. For example, facial recognition used by law enforcement. A recent study published by the AI Now Institute of New York University concluded that a diversity disaster has resulted in flawed AI systems that perpetuate gender and racial biases. Systems that are now being used for law enforcement, for sentencing, for insurance, things that have such a crucial impact directly on people, are failing. Mission-critical systems are failing. And at that point, we might throw our hands up and say, well, if the smartest researchers working on cutting-edge technology can't get it right, what chance do we have? There are factors beyond our control. Who manages us? Who's buying the software? What's making that noise? How will they react to it? How can we influence this? Again, well, it turns out that we have some influence, and it might start with the smallest things. Here's a great GIF, or a little interactive exercise, about how you can have good, fast, and cheap software, but you can only pick two. This is simple, it's trivial, but it explains a point really well. We can show this to the people who manage us, to the people who make decisions, to the people buying our software. If they want the lower price, if they want it faster, are they prepared to cut these corners? Are they aware that they're cutting these corners? We can make people aware of that. And when we're dealing with these complexities, one thing that's going to help or hinder us is the diversity of our teams. Complex software has to meet complex needs of a large number of complex people. It's silly for us to assume that a team that does not mirror that complexity can achieve those goals. And when I talk about diversity, I'm not necessarily just talking about the topics of gender or racial diversity. I'm talking about diversity in every area of economic background, of political view, of age, of educational status. If we want to build good software for humans, we should take the complex and ingenious nature of those humans and mix that together to build solutions that work for everybody. When it comes to solving problems, we're developers. We do that with code. But our main skill isn't writing that code. It's the problems we're solving with it. Can we apply the software principles that we're learning at conferences like this in our day jobs more broadly to the entire way our industry works? We'll often ask a question when we get a bug report. Is it reproducible? Can I reproduce this bug case? What if we ask that more broadly? Do I understand the use case? Do I understand the problem? Do I know what it feels like to be someone trying to apply for a visa to stay in a country with my family when I don't speak the language the system is written in? Does it work on my machine? What biases inherent in the way we've learned, the people we surround ourselves with, are apparent in how we do things? How will it work on someone else's machine, in their context? When we're at a conference, are we so keen to evangelize our way of doing things, our best framework, our best testing methodology, that we forget that other people will have different and yet equally valid experiences? How are we making people feel when they come into the industry? Are we making them toe the line or letting them figure things out for themselves? And finally, have you turned it on and off again? That most classic of software questions. Have you turned it on and off again? Off and on again even. Have you taken some time to stop? To think? To look at the bigger picture? Because if you find yourself moving too fast, you might be breaking things. In conclusion, software is eating the world. This was a statement made by the technologist and venture capitalist Mark Andreessen in 2011. When this was publicized, I saw it as this kind of utopian future that we were all going to build. Software is eating the world. I must confess, I find it hard to be optimistic about statements like this now. What are we meant to do about world-eating software? I think that after testing, design, and considering the human factor, my final piece of advice here is to be humble. Find good ways to do things, but be open to new ways. Make good plans and be willing to change them. I want to finish with a story of part of an essay from the US writer and activist Wendell Berry. Wendell was building a pond on his land in America. And in order to build this pond, he hired a digger, and he read up on all the different things you need to know to build a pond. He brought the digger onto the hill, he dug the hole, he lined it, he put rocks around the outside, he filled it with water, started putting some plants around the edge, and then suddenly the side of the pond collapses. Rocks, soil, and water spilling down the hill, leaving just a dirty, muddy hole. And because it was on the side of a hill, he couldn't even easily fill it in. In the essay, he says that this left a permanent scar on his land. But it also left a visible signpost to everyone who could come past and see it of something he had learned. He remarks that only in sharing these things with community, sharing this learning of the problems with community, do we make right the damage we cause. He says the trouble was the familiar one. Too much power and too little knowledge. The fault was mine. Thank you very much.
Hello? 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 Yeah, no, you guys can hear me. Hello? Have I got a bad mic again? Hello? Hello. Thanks, Mike. Great talk. Easily the best one I've seen today, so well done. I'm not sure why you kept putting that beeping noise throughout it, but each to their own. We've got a short break now. Some refreshments will be served in the, it's called the King George, where you came in this morning, and breakfast, tea and coffee. But before I let you all go, can you just indulge me for a second? Bertie, can I put the house lights up and get a photo of everyone, please? If you don't want to be in a photo,